Hello, welcome back to my Puredata program tutorial where I'm showing you how to make a wave field synthesis system through programming in the object-oriented language Puredata. Last time we did all this. If you haven't seen the last video, then go and watch it because it explains a lot of these basic functions and how they work. There was one mistake in the last video where I didn't do the division in the right order, so I'm going to fix that right now. Basically, what had happened was instead of dividing this by 1, I was dividing 1 by the output of this box here, and that gives you a totally different value from the one that you need. So I'm just going to fix this quickly. So the 1 should be what's getting divided by the output of this, not the output of this divided by 1. So just need to swap these around, and then we're going to add in a volume slider so that we can control the volume more easily, and that's not difficult at all, it's quite easy. And then we will also add in a VU meter, which will show us how much, well, it will show us the volume in decibels basically, which is what we're going to be working in. Because we're working with audio, we'll be working with decibels, which is a logarithmic value as opposed to a linear one. So, right, all that's sorted out now. So the first thing that we're going to do is we're going to add the volume slider. So we're going to put in this object and we'll call it VSlider, and that should give us this. So each channel needs to have its own volume slider, and it connects to the inlet up here. So we connect the inlet of this to the outlet of this slider because this is the controller. So this is controlling the volume in this box here. So if I disconnect these quickly, I'll show you what I mean. We'll test it out. It should work. It's not that complicated a thing. So what we want to do is we'll put on the DSP, and what we'll do is go like that, we'll go like that, and there is our volume. Although I've just realised we shouldn't have done that because the volume, top of this is way too high. We want the top of this to be 1 because we're dealing with a computer that's dealing with audio, and it deals in ones and zeros, a binary system. 1 is full blast and 0 is nothing. So when we had that set to 127, that was like way too loud. So we weren't going to get like a nice smooth slider that just kind of gradually increases the volume. It just went from nothing to clipping and far too loud. So we'll do that again. And there we go. See how it's much more gradual. That's what we want it to be like. So now we've got that working, we're going to add one of these to each of the channels. So we'll just duplicate it and we'll stick it under there, put it there, 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 get one there, and it will connect them all up, so it always goes outlet to inlet, because the volume slider is the controlling object, so it's changing the value inside of this box, because this is our volume controlling box, as I explained in the last video. Okay, so now we've got that. Connect all these back together. Where were we? There, 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 there. I should have explained in the last video as well. Usually when people use Puredata, they connect the outlet of this to both the inlets here. We're not doing that because we're not actually going to use this format of outputting. I'll change it later on, but for the purposes of getting signal through and showing you the basics of this program, it works quite well. But we've only been using the one output, like the one side. We've not been using both sides to output. So what we need to do now is we need to set up some kind of meter so that we can work out what's coming out of where. So to do that, we need to add this object called PVU signal, and basically what this does is it converts this signal into something which, why has that not worked? I'm not sure why that's not worked. That should have an outlet, two outlets actually, and an inlet. Why have you not gone PVUing? PVU. Come on, did I not? Is this not an object? Delete. Object. PVU. Delete. Why is this not working? It's not a message, I don't think. PVU signal. No, I don't think that's right at all, but we'll try it. Can we pass signal in there? Nope. That's not right either. Right, well, we'll put this VU meter here. And we're going to, we need the PVU object to feed it, but I'm not sure why that object won't create. Give me a second. Alright, I've just created it on my other computer, so I'm not sure why it won't work on this. Am I running another version of PD on my other computer? Don't think I am. Come on. Okay, well, what we'll do is we'll make these. We won't feed them yet, but they're gonna be here, just to show us our volumes. And although these meters are useful, there are a lot of numbers on here that you can't see. For instance, it goes from 50 to 30 in the space of a tiny little gap. So what we're going to do is we're going to attach a number box to the outlet of each one. And basically when that runs, it's going to give us the exact value of this meter here. So through that we can actually turn the volume up to the exact volume that we need, instead of just kind of guessing for somewhere in the middle based on what this meter says. So we're going to put a whole bunch of these down here. There we go. Now, the other thing that I forgot to do last time was to create the function that converts this output number from here into a decibel value so that we can actually use it in a way that's useful to us. Because if we get an output here that says 2 and we're using the RMS scale, 2 is well above what we have as full volume. I mean, this goes to 0 to 1, from 0 to 1. So what we need to do is convert this into decibels, and there's a function in dB, or an object rather, that does it for you, and we're going to add it now. Where's that object gone? Right, we're going to add it in here, and what it does is it goes RMS to dB, and that's it. So you feed it an inlet and you give it an outlet that's a number box, and if we hit run and we turn on DSP, turn on the DSP, there's the decibels there. And then when we turn this up, we'll get a value changing in here, and we'll do it until we go from negative 99. It'll start negative 99 over here, and then we'll turn it all the way up by 108 decibels, so it'll be positive somewhere around about here-ish, somewhere here on the scale. Okay, and I have just realized that we have no del rights. Why do we not have del rights? 1, 2, 3, 4, 7, 8. Okay, someone must have been playing around with this program while I was away, because we have no delay lines being written, which means that the delays aren't working anymore. So what we need to do is we need to add del right, and we need to put in a tilde. I'm sure I went over this last time. It's definitely in here. Delay 1, and we'll set its thing to 1000. This was in here last time. And then we're going to need to change all these numbers as well, because these are all variables, so we can't have them all being the same, right? So we'll go along. Uh, 6, 7. I must have deleted that or something. Either that or someone's been in here on this. So we'll copy that and we'll shove it there. These are getting awfully close together. But I can deal with that. It's starting to look a little bit messy, right? So what we might have to do is tidy this up a little bit. I'll probably do that before I end this video. I'll just space out the functions a little bit more, neaten it up so that we can actually read what's going on. We can understand. The worst thing you can have in a program is like cluttered, messy, unlegible, ununderstandable stuff. So let's delay 6. Delay. I'm sure Puredata has like it has a clear up or like unmessifier. It does have like a straighten up thing that you can do that straightens stuff up really quickly, but I'm not convinced by its effectiveness. So we'll just slide that along there, and then we'll start to move them back one channel at a time. Make sure there's a nice bit of space in between them so that we can actually see that these are individual channels, they're not linked. Oh yeah, and then we'll add the RMS to DB function to each of these as well, just before we leave off. And then next time I'll try and sort out I'll have to sort out the PVU object, because that doesn't seem to be running the way it should be. What are you doing? Right. There. Now we just want to do this. Duplicate that and shove it there. Link it, duplicate it. Link it, duplicate it. Link it, duplicate it. Link it, duplicate it. Gonna have to move that too. Oh no. Oh, that did duplicate. And that shouldn't be there. Right. Okay. So basically, what we've done today is added in this RMS to DB, fixed the del right function so that all the delays are going to be working now, and switched around these divisions so that they're the right way around, so we're getting the right output. And that's it really. That's it for today. I'll try and sort out the PVU thing so that we can get a reading in these meters here, because without the PVU function I think these are kind of useless, unless this is a version where they link like... Is this a version where they link on their own, straight in? No. 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 No chance. Okay, so I'll sort out that PVU function object for the next time, but basically now we've got the decay being calculated and getting a valid output in decibels, and then we've got the time being calculated and giving us the delay that's valid, and the next thing after this will be to load files in. So we'll have to say goodbye to the oscillators, because they're going to have to come out if we're adding in files. But yeah, that'll be it. So thanks for watching, and see you next time.